Hello science fans, welcome back to Science Fun with Austin. Today we're going to take a look at ablative thermal protection systems. A material commonly used for that, even in aerospace, is plain old cork. Today we're going to take a look and see if regular old cork does the same thing as aerospace cork. With a simulated heat source and plenty of plain old cork available. As you can see there, ablative means that the cork burns away as it's heated, and the chunks of it that fly off as it burns carry heat away from the system. So that's what ablative means. Let's see how well regular old cork works. Alright, so you can see here we have a thermometer installed, and it's reading about 76, and we'll apply the heat to the cork. You definitely see the cork is burning away there, but the temperature actually isn't really moving very much. And you can see little bits of the cork ablating away, as cork is wont to do. But this particular cork is working really well. I think we finally started to burn through there, so we'd better stop. But we did actually provide pretty good protection. Alright. So you can see we're at about 78 degrees here. I'll try another sample. This is a little lower density cork, doesn't seem to be performing quite as well. And you see it burns for a little bit even after we take the heat off of it. It does look like the type of cork you select for your thermal protection does matter. The wine cork did not do nearly as well as the whiskey cork. Alright. This one looks like it feels like a fairly hard, high-density cork, although it does seem to have a little surface porosity. Let's see how it does. Temperature is hardly budging. Finally starting to get a little heat on it, but there we go. We finally looks like we finally managed to burn through it there, but that smaller cork sample did pretty darn well. Alright, this one kind of looks and feels a little like an intermediate density cork. Performing pretty well. You notice there's not much heat going from the front of the cork to the middle where that temperature probe is. The back side of the cork doesn't really know the front side is on fire. You can see all the little bits of cork ablating away. This is pretty much ideal thermal protection here. That is working great. I think this particular cork sure held up well. Alright, so we'll take a look at it in infrared. Again, you can see the cork burning away. This time we have actually managed to light it on fire. See the temperature starting to go up. This was kind of the core insulating cork, but it is pretty easy to put out. And once you have a nice layer of char, it tends to smolder, but it goes out pretty quickly. Alright, well, I think we've seen that that cork actually can do its job as an ablative TPS system. A propane flame is typically about 3,600 degrees, and if we just stuck the probe from the meat thermometer in the propane flame, we'd have a liquid pool of used-to-be meat thermometer. And the cork did a pretty good job of preventing that. For a thermal protection system, it does matter what kind of cork you use. We definitely saw a difference from kind of the puffier wine corks to the more solid bottle corks. But all in all, I think we demonstrated how an ablative TPS system can be effective on kind of a budget. Hope you enjoyed that, and see you next time, science fans.